Hello, everyone. Welcome to Unstoppable Rollups Community Call 3. Unstoppable Rollups is, of course, a collective dedicated to rollup unstoppability, to increasing the number of rollups that cannot be stopped by anyone. We are generously funded with a grant from the Ethereum Foundation, and these community calls are our way of engaging you all in this conversation. And so this is call number 3. The title of this call is Are Sovereign Rollups Amazing or Terrible? This is a little silly, but it gets at some of the motions involved here, because what is a sovereign rollup? Well, we're going to see. Do we even really agree on what that is? But whatever it is, people love them or hate them, and by love them or hate them, I mean hate them, basically. Everyone hates them. And so what we're going to understand in this presentation is why haters are wrong, and in fact, sovereign rollups are the future, and we're even going to make a stronger claim, which is sovereign rollups are the present. Okay, so you can't escape, haters. Sorry about this. So, and there's going to be some Q&A and discussion. So, okay, what is a sovereign rollup? We got a chat message here. Celestia, folks, love them. Okay, so that's a good point. I should mention this. People love to hate on Celestia. Celestia loves sovereign rollups, but when it comes to Ethereum rollups, using Ethereum as data availability, they are much hated. But shout out to Celestia for pushing forward the discourse here generally. So shout out to Celestia. So what is a sovereign rollup? Well, okay, we got to start with what is a rollup. And as always with this kind of presentation, it's like, hey, it's not so easy. Okay, what a rollup is. So let's do it. A rollup is a function. It's a set of rules. It's a protocol. It's made up. Right? It's not real. It's like driving on the right side of the street. It's just a set of rules. It's a function whose input is the Ethereum L1 chain, so the state and history, and its output is a blockchain. And a blockchain is state plus history, so blocks plus state. And if we drill into this a little more, what we see is this function is actually two functions. And this is where it gets a little tricky, and I really want to be precise about this, and trust me, it's important. Rollups, just like the L1, have two layers: consensus and execution. Okay, we all know about execution because rollups do off-chain execution, and that's the whole point of them. And this is all really important. But consensus, it's like, what is consensus? Like, really? Like, that's more of an L1 thing. But you need it. Why? Because you need to know what goes in the blocks. So you can execute the blocks and go from state A to state B in the rollup. But what goes in the blocks in the first place? And obviously, what goes in the blocks determines the truth. So how do we build the rollup blocks? And that's what consensus does. And then execution runs the EVM or whatever version of EVM, goes from state A to state B and stores the new state B. Now, as I mentioned, we all know execution is off-chain. That's the whole point. But where does consensus live? What is the deal with consensus? Trust me, this is important. Okay, so what's interesting about this is when it comes to consensus, the thing that people think they know, it's like not what actually how it works, but how it maybe should work intuitively. So what I mean by that is, here is what is called on-chain consensus. Okay, here's an example of on-chain consensus. That means a smart contract is obviously involved. It's on-chain. So this is how a rollup might work. A sequencer, or anyone, posts a block, a rollup block, to an L1 smart contract. The smart contract verifies the block using a proof, either fraud ZK, whatever, fault ZK. And then after that, the block is in the chain. Okay, so this was kind of the original idea for rollups. This is how most people actually still think they work. And the pro is that it is intuitive. This is kind of like how they should work. If you just look at them, it's simpler. And it's also convenient because now you have an on-chain source of truth. Now, the fact that this isn't how it works is what gets you some stuff where people say, oh, optimistic rollups have 7 days to finality, right? That incorrect statement is based on this mental model. Okay, so what are the cons of on-chain consensus? Well, one issue is you have to prove every block, and yet the proofs don't tell you anything. Meaning that any observer, right, any node, right, any person will always know whether a block is valid no matter how the proof turns out. So you have to spend all this money proving stuff, and the proofs don't really tell anyone anything, except in the case that a user is trying to withdraw, which is not obviously every block. In OP, you reorg whenever a fault proof is won. In other words, whenever a block is proved invalid and a fault proof, you reorg. That can be a 7-day reorg. You don't want to reorg the chain 7 days. And then most importantly, in the mutable case, and we're becoming mutable rollups in this presentation mostly, you don't want a smart contract to be the source of truth, because then the governance of that smart contract can change the truth. That's super powerful. Okay, so this is the old model, and this is unfortunately how people still think it works today. This is the new model, off-chain. So in off-chain, anyone does anything. Okay, the off-chain model has no thing where it says what people are supposed to do. People can do anything they want. People post garbage on any blockchain, probably the L1. They're going to post stuff on the L1. Then an off-chain node observes this and extracts the valid postings and build blocks. So for example, it'll say, oh, you posted this? Well, you're not the sequencer, so sorry, we're going to ignore you. So it ignores things, right, that are invalid. It builds the blocks. This off-chain node, or rather the rules that it implements, are the source of truth. And then we prove the state to quote-unquote light clients. We're going to say what those are in a second. Okay, so this is very different, right? It doesn't matter where you post. It doesn't matter who posts. All that matters is you have a node that can look at this stuff and extract the true thing. So this is like the opposite of the previous slide. Okay, so what is the summary here? All right, and this is, off-chain is the dominant paradigm today. All the big ones are using this. Optimism, the best one, is using this. There's a lot of benefits to it, and here's the summary. So rollup blocks are derived from the L1, right? If you think about like forced inclusion combines batches sequencers post with transactions users put through a smart contract into blocks, right? It derives a block. The entire block is never posted, okay? Proofs communicate truth in the off-chain world. They do not determine it. Now, even in the on-chain world, they certainly do not determine it, but from the standpoint of the rollup state, rollup can be programmed to follow incorrect proofs, from the standpoint of rollup state. Finality reorgs track the L1. So the rollup is final when the L1 is final, right? The postings on the L1 is final. The rollup only reorgs when the L1 reorgs. A proof system cannot reorg the rollup. And this is our focus today, although it's not really that essential for the argument, but just this slide is really important. Just here's how you should kind of think about this oft underlooked part of rollup state transition, or rollup derivation. So, okay, so that's consensus. Let's talk about how to use a rollup and how to have a full node. So this is all pretty basic, but we got to build. We got to build towards the sovereign thing. So full nodes, you all know what a full node is on a rollup. You have to choose your rules. Again, the rules are a combination of consensus rules and execution rules. You have to run an L1 node, and to do that, you need to choose your L1 chain, and there's weak subjectivity and all this stuff that makes that maybe not trivial or maybe fine. Then you run a rollup node corresponding to the rules. You connect it to the L1 node. In the case of Optimism, there are two nodes you have to run, or two pieces of software. One is consensus OP node, one is execution OP geek. And then you make your RPC calls to your rollup node as you get the state and history there, and you are good. So pretty simple. Okay, now we've got this light client idea, and most people are probably familiar with this as well. But basically, the issue is that if you want to run a base node, you have to use it's 500 gigabytes per week. So good luck doing that. You can't do it. So light clients, you don't get all the state, but you get enough to adjudicate claims. You get to say, like, does Alice own 1,000 USDC on the rollup, or does Alvin burn 1,000 USDC on the rollup? You can answer these questions about the state using the state root and storage proofs. And so the question is, how do you get this piece of information, state root? We all know what state roots are. You use proof systems. We all about this. Okay, fault proofs, just quick refresher, right? The way this flows, right, is it starts from a state root from a full node. Again, full nodes have the truth. You get the state root from the full node. You post that state root and run a proof game. And then depending on the outcome of that proof game, you can accept the root in the contract. And of course, the rules of the game have to agree with the rules of the full node, because otherwise you're not going to be communicating the truth of the full node through the game. And if the proof doesn't go well, of course, as we mentioned, it doesn't change the truth. It just means you now have a faulty, I shouldn't say faulty, a not good working full node. Okay, another thing that shouldn't be, because I'm building here, another thing that everyone should not be so surprised about is that rollup bridge is a light client, and in fact, the dominant light client use case, basically. And, or not necessarily dominant, but the one with all the money involved. So why? Well, because, you know, the bridge has to ask these types of questions, right? This type of question where we say, you know, who owns what on the rollup, the bridge has to say, well, you know, is such and such claim on the L2 consistent with, you know, Alice withdrawing, but we can't run a full node, obviously, so we have to create a light client. Now, anyone can create a light client, right? Because all you have to do, again, is run a fault-proof game. And a fault-proof game requires someone with a full node, and it requires rules of the game, and it requires implementing those rules in a smart contract. Anyone can do that, right? Anyone can run a light client. Anyone can run an equally secure roll-up bridge, okay? Another nice property here, and this is something that is pretty cool, is that if you have an L1 node, you automatically have a light client. So what this means is because because smart contracts are obviously implemented on the Ethereum execution layer, you don't have to re-implement your own light client. You can just reuse one, which you can use yourself with an L1 node, provided you know a bridge that implements the rules that you like. So you have to still choose the bridge, you have to choose and make sure the light client works to your liking. But if you choose that correctly, you and anyone else who follows that those protocol rules can get a light node automatically without writing any software, which cool. Just admitting some people here. Okay. So now with all of this, let's talk about a minimum roll-up. Okay. Here we go. That's a chill roll-up according to me. So we define our rules off-chain. So this is true in the case of you know, the rules of a roll-up. All rules are defined off-chain, right? Because you have some rule in your mind when you create a smart contract, right? Everything's defined off-chain. But this means the protocol rules in terms of what is valid and invalid is defined off-chain, not based on what a contract has to say, happens to say. So this is the off-chain consensus. Anyone can run a roll-up node. Okay, this pretty basic. This is like kind of the definition. You need to have a source available node. Okay, good. Anyone can run a roll-up light client, right? This is what we said a moment ago, where all it takes to run a light client is at least one full node and the ability to implement the rules of a challenge game in a smart contract, and anyone can do those things. Anyone can run a light client. Anyone can build a bridge, because a bridge is a light client. So we have this roll-up. People can bridge in. People can withdraw. People can validate this using a full node. People can validate this using a light client. This seems pretty nice, right? You get your good stuff. You get to know the state. You get to do the bridging. This is what people like doing rollups. It's great. And of course, the punchline here, okay, this is a sovereign rollup, right? The thing I'm describing right here, this construct. And so, you know, obviously one thing to point out is like, this is like pretty simple, right? Like it is simpler to come up with a sovereign rollup than a non-sovereign, as we're going to see in a second. And also, why the hate? You know, y'all, like this looks pretty chill. What is the problem with this design? Okay, so let's get into it. So what is a sovereign rollup? Well, it is something to do, and you can ask a lot of people about this, but it is something to do with the relationship between the rollup protocol and the light clients, okay, and the bridges in particular. And it's very basic. In a sovereign rollup, all bridges are created equal, or just are equal. You know, you don't have to pull in this whole language there. So there is no way anyone can build a bridge, right, in our minimal rollup, and everyone's bridge is equally secure as long as it's programmed in a good way. There's no equally functional, equally secure. There's no way to say a bridge is better than another bridge. Sovereign rollup, all bridges are equal. In a classic rollup, which is the non-sovereign, all bridges are equal except one bridge. Okay, and that is the enshrined bridge. Okay, you could also call classic rollups enshrined bridge rollups, and we're going to get to what that means in a second. Sovereign rollups support all classic rollup use cases. Anything you can do on a classic rollup, you can do on a sovereign rollup. And classic rollup support permissionless bridge creation. So if you go to Base right now, you can create a bridge that is just as secure and just as everything as the main canonical enshrined bridge. Has no issues at all, complete permissionless. You can do that on Base today. So there is no way on a classic rollup to hold you back, right? You can do that because anyone can create a light client. So that's a solid rollup. So what is an enshrined bridge and what are the benefits? Okay, so an enshrined bridge is the bridge that is special, and it's special typically because it handles deposits and withdrawals of the native currency. So there's only one native currency, and if you want to deposit into a bridge and make that native currency balance on the L2 go up, right, there is only one bridge that can be allowed to do that because there's only one balance, right? So one bridge per balance. So it allows you to increase your native balance. This is typically what it does. And it is the Schnelling point. The Schnelling point is just kind of like a thing that people pick to agree on, even if it isn't objectively better than other things. The Schnelling point, focal point for bridging other assets, right? Why do you want it to be the Schnelling point there? Well, we'll see in a second. And the Schnelling point for the rollup rules themselves, for understanding which version of the rollup you want to use. So we're going to discuss both of these quote unquote benefits now, right? Two benefits, right? You can do this native deposits thing and you get the Schnelling point. Okay, so what are these benefits? Are they real? So first benefit is the gas token, quote unquote benefit. So if you have an enshrined bridge, you can use bridge ETH as your gas token. Okay, if you don't have an enshrined bridge, then you can't. Right? You have to use a native token. You can't use a bridged token because who can build that bridge? It has to be built into the protocol. So this enables bridged ETH, but it also enables bridged USDC or anything. Optimism famously had a whole setup for custom gas tokens, which they now deprecated. Whatever. The point is, if you want some outside bridged asset to make your native balance go up, you need an enshrined bridge. Why is this good? Well, it's familiar L1 users use ETH in both places for gas, and devs like MSG, message.value, they just like that for some reason. Basically, it's simpler. Previously, with approvals, this was really important, but 7702 makes less. Okay, bad or irrelevant, paying gas is a terrible user experience. So why, who cares what the currency is? It's terrible. So, no points for being a little bit better. It's all terrible. And so, we need to abstract gas. There are ways to do this now. If we want people to use crypto, we have to use it more. And also users must be able to pay in ERC20s as easily as the native currency. Message.value has to die, unfortunately. Like, we cannot be so attached to Ether for these things because they are not friendly to users. And so my view is that if this gas token thing is a benefit of enshrined bridges, then we're screwed anyway, because this stuff has to be abstracted away. Okay, now to the second quote unquote purported benefit. Is it a Schnelling point for rollup rules? Well, here's the argument. Everyone has to use it to get gas. Might as well use it for other assets too, right? Like, it's no worse than in a bridge, and having multiple bridges bridge the same asset is not good. It's confusing, so we might as well use it for other assets. Might as well use it as our light client too. Like, everyone has access. Might as well, we need to use it as a light client and take it for, seriously if you want to withdraw from the bridge. And so therefore, the enshrined bridge, if these things are true, right, it can function as the source of truth because there's no better option. You might as well use it, right? Like, it's good for these reasons. We might as well use it. Can it be the source of truth? And so I'm going to argue that this argument is totally bogus, or at least not totally bogus, but does not lead to this conclusion. Okay. So the first thing to understand is that looking to the bridge as a light client, it is a social commitment, right? It's basically everyone hanging out together, having fun, and saying, all right, let's just do what this bridge says. Let's follow this bridge, right? It is not real in the sense that, any rollup rules, no one can compel you logically to follow one proof system implementation or one set of rollup rules. They're not better or worse than any other ones. It is a social commitment. It does have teeth, which is if you disagree with the bridge, you can't withdraw, right? You have to run the same rules in your head, in your life. You have to accumulate assets on the L2 under the same rules you're going to use to withdraw from a given bridge. Now, this kind of gets to why this argument is bogus, because this argument is not related to the enshrined bridge, right? This argument applies to any bridge, right? You could have a social commitment to follow any bridge, no logical reason to do that, and every bridge has teeth. If you disagree with any bridge, you can't withdraw from it. So this might apply to the enshrined bridge, but it might apply to any bridge or no bridge or whatever. And the reason it might not apply to anything is we have to have kind of a mental model, like how does this actually work in practice, right? Users don't just flip a coin, right? Users follow the fork where their assets are most valuable. This is pretty basic, right? Like, I don't know, maybe people are having other stuff to do with, with rollups, but you want your assets to be worth a lot. Okay. One consequence of this is whoever controls the biggest pot of redeemable value sets the effective fork, right? Given two forks, users will follow the one where their assets are most valuable, and that in general is going to be the one where the one that is set, that is proposed, that is followed by the coalition, the group of people that control the redeemable value that users want to get. Okay, and so now we can ask this question. Will this coalition be the rollup admins, and will their tool be the enshrined bridge? Right. This is an empirical question. Okay. If you love enshrined bridges, you unfortunately have to contend with this empirical question. You can't just assert that it's true. And is it true? It's no, it's not true. In other words, it's not the case that it will always be rollup admins. It's not even true today. Okay. So this is a rough story for haters for lovers of the enshrined bridge. And the reason is because of stablecoins. Okay, stablecoins are the killer app. If you're out there thinking, hey, like I'm trying to do stuff with, Ether or NFT, like great, I love that. So am I. But in the future, the game is the stablecoin game, and we have to respect that because that's going to bring actual real people to use this stuff that we're building. So let's respect it. And so if you look at Base and Arbitrum, the two biggest, you can see that stablecoins combined with other non-canonically bridged assets, other native assets, they dominate the bridges. Okay, so Base is 40% of the TVS is canonical, so it's 60% sovereign, right? That's how I say it. Arbitrum, 29% is canonical. It is 71% sovereign. These are already sovereign today in the sense that given the choice between two forks, the canonical bridge will lose if the other fork manages to get at least 50% of the total TVS on its side. Okay, so it is game over, basically. Okay, we have to live in this world, or you could bet on it going away, which I would not do that. Don't do that. Okay. Enshrined bridges don't work. They don't work because the gas token is irrelevant. Who cares? It doesn't work, and they don't work because they aren't a Schnelling point. Okay, today, and they're going to be less so in the future, right? So there's zero benefit, but at least they're harmless, right? Right. So I made this meme here. Enshrined bridges aren't Schnelling points. Misspelled Schelling. It's AI. At least they don't have massive fatal down. I mean, I'm 41, so at least they don't have massive fatal downsides, right? At least they don't have massive, but no, of course they have massive fatal downsides, and this is what is absolutely insane about the hate that sovereign rollups get. So, downside one, they're completely insecure, right? That's a pretty downside. So, rollup admins cannot, in general, use enshrined bridges to dictate the fork. Right? Maybe they could in some world in the past, something, but they can't today, and they can in the future in general. But here's the kicker: they can use it to nuke the chain without forking. Right? So in one sense, they have no social power, but in another sense, they have unlimited hard power because they can nuke it. How do you nuke a chain? Easy. You upgrade the bridge. Whoops. You upgrade the bridge. You issue infinite L2 ETH to you and your friends. And now gas is impossible to buy for anyone else because you can bid up the gas price infinitely. And so you just devalue everyone's native token and it's done, right? Yes, you can use forced inclusion, blah, 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 but it's a really big, bad thing to happen. The chain is nuked in this case. Stablecoin issuer can fork, right? They can fork away from this, and they have the power, and they can fork to a chain where gas works differently. But that is not a fair fight. Forking is hard. You got to come up with things. You got to upgrade node software. You got to do all this stuff. Nuking a chain in place is so easy. It takes 2 seconds. Costs $5. That's not an even fair fight. And basically, you got to ask yourself, like, why would any stablecoin issuer choose a rollup that has this risk? Right? The answer is they won't. Period. If you are a stablecoin issuer, you do not want, in the case of Base, for example, 15 signatures and maybe one person to be able to nuke your whole setup. Right? You're running the show. You're providing the value. You don't want someone nuking you. Why would you want this? And for no benefit. So what we're going to see here, I believe, is in the long term that rollups that are not sovereign cannot compete for stablecoin business, and that's the most important killer app we're dealing with. So it's a big issue. Okay, do exit windows solve this problem? No, they don't come close. Next question. We already went into this, but just like it's really bad. Okay, immutable bridges would solve this. Okay, there are other trade-offs there, but I think if someone wants to create some immutable bridge stuff, create a immutable bridge rollup, like they should do that, and this would defeat a lot of these arguments and change the game. I am arguing against traditional, big time, the big players, which are all mutable and that, whatever. But like this is a really important thing to point out. So we're going to cover this in future stuff and calls. But like, please research immutable rollups because that's a different ballgame. Okay, so now I'm about to criticize L2Beat. So before I do that, I have to just emphasize they're the best. They're the only ones out there doing anything. So easy to criticize because they're the only ones. Shout out to Luca, who was super helpful in this. Read L2Beat. You can become an expert. And so now I will criticize with love. So the downside to, and maybe this is the worst downside in a way, is enshrined bridges create a fundamentally incorrect security model in the minds of users. Okay, if we look at L2Beat, we see there's a pi. This is a famous pi. Okay, there are, I guess, 5 wedges, and these wedges are supposed to be components of rollup security or rollup decentralization or like good stuff about rollups. But they're not created equal. In particular, 3 of them, which I've highlighted here, state validation, exit window, and proposer failure, only apply to assets in the canonical bridge. So if you were looking at this and you see green, then you should feel good about 29% of the assets on the rollup, right? So that should have the number 29% in there, right? It's not for everything. Sequencer failure data availability applies to everything. They are more important, right? So this is not to say we should ignore the canonical bridge or enshrined bridge. We should not. We should look at all bridges. Every rollup on the asset should be analyzed and users be educated about them. All bridge operators and all asset issuers should be accountable, right? We cannot just hold the enshrined bridge accountable and tell users that because of that, they can ignore the other bridges. It makes the rollup look safer than it is. And we have to place greater value on rollup properties such as the ability to continue transactions, right? Forced inclusion, this kind of stuff that affect all assets, right? This is called unstoppability. This is the reason we're all here. We need to create a greater emphasis on stuff that influences more assets, all assets. So because it is good to not just complain about things, it is also good to suggest ways in which they may be better. Here is my proposal for L2B. Okay, there are 3 sections. Section 1, rollup properties affecting all assets. That's here. Okay, this is whatever, the things surrounding the ability to drive state, which is data availability, and the ability to get your thing in and not have censorship issues. So this applies to everything. This is the unstoppability, basically. Now we have the bridges, and we list every single bridge, all equal, right? We don't say, oh, enshrined is the more interesting one. We say the most interesting one is the most that has the most value in it, and not just every bridge, every natively issued token, every asset. We say how secure they were. And we say, do they have a proof system? Do they have an exit window? We apply that to every single one. And then 3, we let users connect their asset, connect their wallet, and it analyzes their wallet and says, here's how secure your assets actually are. Okay, so I think that this paradigm is a lot better, and being stuck in the enshrined bridge model means that this will never happen. So I'm going to try to convince Luca to do this, but I don't think it will happen because the enshrined bridge is so deep in. So I'm going to try to do it. So, okay. what's the conclusion? Today's rollups are sovereign already. Sorry, everyone who hates them, and they're getting sovereignier. Oh, sorry. Here. How do you? Yeah, please mute your. Okay, I'll mute you. Okay. They're getting sovereignier. Sorry. The benefits of the enshrined bridge are gone. They're zero. Okay. Sorry, it's true. Just look at the stats. And the downsides are huge and remain will be here forever. Okay. Upgradable enshrined bridges are hostile to native assets. They are holding rollups back. They are hostile, outright hostile to native assets because they give bridge admins the ability to nuke the chain. So if you want native assets on your rollup, you should not have an enshrined bridge, especially if there's no benefit. Sovereign rollups are not a quick fix, right? If you have a sovereign rollup, that doesn't mean, hey, everything's all good. I can have a terrible bridge. I can have garbage here, like just because I'm sovereign. Not true. You still need exit windows if you have, that's the best you can do. You still need proof system. You still need all these things, and it's actually harder because you need to admit you need them for every single bridge, right? Or at least you need to know users are exposed to every single bridge. So sovereign rollups aren't saying we don't care about bridge security or we're a quick fix. We're saying all bridges we care about. And so it's the beginning of work, but it's the beginning of the work on a better foundation. They're a better way to build rollups, and we have no choice. And we have no choice. And also, we need to make sure that we welcome asset issuers, not reject them, which is what current rollups do, which is never going to work. And so thank you all. That is why sovereign rollups are dope. I shouldn't say dope, but 41. Thank you. Any questions? No questions. Have I muted everyone? Come on, Sam. Come on. Surely I must have. I was really trying.
I mean, no, I have no questions. I think it was actually, it was good. This was better than I thought it would be. I think you did a good job, Tom. You've made some very convincing points. I mean, I have like a whole little retort prepared. I have a little presentation even I can share if you want.
Do it, yeah.
But I think you'll be intrigued to see that we're coming at this from a very similar point, and I think at the end we honestly might agree. And that's gonna be my goal, to try and change your mind here. But
yeah, I mean, certainly when it came to the exit window thing, seemed like we were a lot closer once we actually started talking about our views. So this is the healing process, actually talking about.
Yeah, no, I mean, like with exit windows, I think we both agreed it's like the bare minimum.
Yeah. Okay, so I need to give you the ability. You made a presentation. It's amazing. I need to give you the ability to do something. I will add you. Maybe I'll add you as a co-host. Will that give you the ability to present? I have to turn off general ability to screen share because of like horror stories and so forth. But see if it works now.
Yeah, it looks like it worked. Can you see my? Let me turn my camera on too. We'll get real serious here.
I love it. I love it. All right.
I won't put on the mask. Right? I was wearing this with Boris the other day, but
yeah.
No, okay. Let me share this real quick. We'll go through it. All right. So, my take about sovereign rollups. I believe that they are alt L1s in the form that we discuss, and there's a critical difference that Tom mentioned right at the end of his presentation that can salvage them from my perspective. And so we'll start with a very simple example. Let's look at Binance Smart Chain. Basically a clone of Ethereum, runs our EVM, runs ETH, I think, for the majority of its network. We would all agree this is an alt L1. It has separate nodes. They're running their own consensus. They're storing their own state. And then totally detached from that, we have Ethereum consensus and Ethereum execution. Let's imagine that BSC started using Ethereum for data availability, right? So it's putting its data into blobs the same way a normal rollup would or a sovereign rollup would. I argue that this does not automatically and magically turn BSC into an L2 or any sort of reasonable scaling solution for Ethereum. Now, just because it's doing the thing that a sovereign rollup does, and I can run a node, and my honest node can derive the state of BSC from consensus, I don't actually think that this is good enough. I still believe this is an alt L1. And you can see, the BSC majority can just decide to stop posting any data to Ethereum. It'll fork. My little node will go on its merry way, but I'm not actually, doing anything, right? Users could join my honest fork. They could run their own nodes, but the execution layer of Ethereum cannot see any of that state. There is no proving system. And I argue that we need the proving systems if we're to actually be any sort of mechanism for inheriting Ethereum security. And so here's the optimism example, right? Once the optimism would post data to the consensus layer, I would be able to run my honest minority node. I would be able to submit proofs to the smart contract, and then I can go ahead and have my state in the execution layer. Now, all this to be said, like, optimism is not sovereign because it has this ability. And so I think this is what matters, right? And 7-day finality, I don't think that's just a meme. That's simply how long it takes to get a state root proven to Ethereum, to any smart contract. I'm glad that you mentioned that bridges have teeth. I think those teeth are the entire point of the bridge, right? The L2 can fork away and we can still maintain independent state. And particularly what you mentioned with like the bridge asset valuation and the stablecoin fork choice concern. None of that applies to non-financial use cases, right? So if I'm doing any sort of, value-free computation on an L2, I don't necessarily care if my bridge is not the majority bridge because Circle didn't enshrine it, right? I can still have a trustless proven bridge to Ethereum and I can get my state roots home, and then I can deploy that same version onto multiple different L2s. I can compose between them. I can use L1 as the messaging relay. And I agree with you. This was the original vision, and it's my act of heterodoxy that I still think that this should be the vision and that this is what actually matters. But where we do agree is I also don't necessarily care about the enshrined bridge, right? And we discussed this in Telegram a little while, right? You mentioned that, like, Facet, for instance, if you set up a proving system and I can have proven state on L1, I argue at that point you're no longer sovereign, right? You're non-sovereign because I can simply look at that fork on that smart contract, know that that was proven state from your sovereign rollup, but I can treat it as identical to any other rollup. So my point is I have beef with sovereign rollups, but when you introduce provable bridges, they're no longer sovereign. So I think we're definitionally disagreeing, but yeah, go ahead and get proven bridges. That's all that really matters. But you're not sovereign anymore because you can fork, but I don't care. I don't have to follow your fork. I can still be my brain in the jar on an Ethereum smart contract, looking at your state at that moment, and I can have strong guarantees that you didn't, violate your own state transition function. And then we agree on all the other problems about, bridges shouldn't be instantaneously upgradable, if ever upgradable, and all the likes. So
super. Yeah, I think this is great. I think we are very close. I really tried with the presentation not to get caught on the, and then Luke is always bashing me for this. Like, are we gonna just talk about terminology here? Because, like, yeah, ultimately, like, we agree on the fundamentals. Reality, it's like, let's not stress the terminology so much. I'd say 2 comments. One, I think, is a very reasonable thing, and I think something that's been a bit of a mistake in the sovereign world of messaging about sovereign rollups, and also just in no, they're not L1. Sorry, I don't care about. Sorry, I don't care about terminology. That's what I was saying before. But sovereign rollups, L1s. It's like you look at L2B. It's like a sovereign rollup is a rollup without a bridge. Rollups have no bridges. There became this meme where you don't need a bridge at all, right? You don't need a validating bridge. And this was exacerbated by L2B's rules, which said you don't need a bridge to be a rollup. Now they've changed the rules, and we're about to get screwed over by this, I think, where they say you need a proof system. And what I take that to mean, and I agree with this, is that to call yourself a rollup, and I think to call yourself a sovereign rollup either, you need to be able to build a light client. You need to be capable of doing that. There needs to be a way to do it. It can't be impossible. So there must be a way to build a light client. Therefore, there must be a way to build a bridge. Therefore, there must be a way to build as many bridges as you want. If you deliver a protocol that doesn't have this, which unfortunately is like Facet today, then I think you're well within your rights to say this isn't a rollup, period. And that's what L2B is about to do. And so we have to make this light client thing. Now, the other thing I would more disagree on is this important of proofs, because you're saying, I'm saying you need the proofs, the proof system to be considered a rollup. But as to the importance of proofs, as to whether we should value them, Unfortunately, the market disagrees with you and with me, I guess, probably on this. In other words, the market doesn't care about proofs because, and we've seen this because the market loves centralized stablecoins.
Oh yeah, I mean,
and so
market's wrong.
I know. Well, the market's wrong. That's one view, right? But the stablecoins seem to be going up, up, up. And it's like, what is wrong? You know, it's like we need to build these products people are going to use. That doesn't mean we say that security is not good. We just accept the way things are going and try to build around that. So when we say, some rollups are bad, which I take to be rolls without bridges are bad, and let's build better things, we don't have a choice, right? Because people aren't just going to start using these bridges just because they're there. They're already not using them. So I think there's a broader question of like, how do we make these things secure? That is not just build a secure bridge, which is still upgradable and not secure, and expect people to use it. Like, how do we actually do this? And to me, and this is why we're here, to me, the number one thing is if people want to issue native assets, we got to worry about protecting that just as much as we worry about protecting bridged assets, and in fact more. So I think that's the, and I don't think you're disagreeing with this, but I think basically I think that what you're saying is very true and important. We need these bridges, but also we need an approach to rollup security that acknowledges the current reality, which is native assets are, I was literally surprised to read this. Like, I remember I mentioned Satya's Twitter post. I should know everything about this, right? Like, this is my obsession. And yet when I read his Satya's post, I was like, what? And then I was like, whoa, that's weird. I look at L2B every day. It's like, it's very weird that this is true, today, even from like my perspective. But anyway, yeah, I don't think we disagree about very much. After all, so now you can recant your thing, or at least you have to label my thing differently.
No, your thing doesn't have proofs yet. That's my point.
No, my thing being my presentation here, the concept of sovereign
okay,
rollup, not my other thing, not facet.
No, well, my only point is, as soon as you add the proof, once the sovereign rollup gets to the point where it's acceptable to me, I would no longer call it sovereign, because you have bound state in the smart contract that's proving everything, and I can look at that, and I can, as an Ethereum execution layer, you can fork and do whatever you want, but that bridge with that state will have teeth, and now you are equivalent to any other rollup. You just don't have an enshrined bridge.
Yeah, and I'm saying that's my definition of sovereign. I think the thing you're saying is basically also reasonable, which is collapsing the two and basically saying all rollups with proofs are in the same bucket. And therefore, another way to say that is Base is sovereign. And I think that's also a reasonable thing.
No, Base is not sovereign. Base has an enshrined bridge. You can be, I don't care about the enshrined bridge. That's where we agree. Have proof. You can have 100 bridges. If they're all proven, you're a rollup. Or if any of them are proven, I can follow that bridge and have a rollup like security construct across that one bridge. If you have no bridge, then you can be sovereign.
Yeah, sovereign. I mean,
then you're an alt-L1.
It means to me no enshrined, but then what's the value of enshrined? How much money is in it? Imagine, this is in Charbonnel's article, imagine an enshrined bridge that has $0 in it. Like, good luck making that a focal point. So yeah, it's a question of degree. I think what Satya wrote.
Well, my point is, the $0 bridge, you can still get state across though, and this is where I'm I'm looking at this very non-financialized aspects, right? And so there was some friends of mine, they have done some recent work with Norhack. They're working on like, a kind of cross-chain Tornado Cash ZKP style construct where they have to integrate on L1 across all these different L2s, and they have to wait for state. Now, they're not doing anything financial, but they can't receive state from Optimism without waiting a week. They can receive it from Scroll much faster as soon as the ZKP lands, but then they have to, copy it all themselves and make sure that state isn't being manipulated by the instantly upgradable bridge. Right. But the point is, like just being able to integrate with stuff, that construct can never integrate with a sovereign rollup, right? And so
the $0 bridge still tells you the state, but it doesn't do the Schnelling point mean because there's no teeth, because there's no money in it. So I think it can still do the social contract thing because it's not all about the teeth of the bridge. It's also about just like, it's good for people to agree. Like, total chaos is bad. It's not like there's still incentive to agree. I would draw the attention to such as chat message here with this Kelvin Fincher tweet. If you do some research on this, like you read that article I linked, you'll see this guy's all over the place. I DM'd him actually for this talk. No response. Sorry, no, Kelvin. It's cool. You're a busy guy. But great thinker on this, and also really, I think I copied a bunch of his stuff. I agree with him. And
well, I disagree with the optimism guys actually, because I've fought with them about this finality thing. I think finality is realistically when the L1 smart contract can see it. I don't really ascribe to the notion that as soon as you're in data availability, you're finalized, and then therefore the finality of every single rollup is, 15 minutes, whether you're ZK or optimistic, right? I think ZK constructs that can achieve this hard state on the Ethereum L1 much faster than optimistic rollups are commendable, and they're just simply better because then I can have my L1 application actually do things with that data, right?
sure.
And so, yeah,
But
but yeah, no, I see what you're saying.
I'm just saying how it's defined, right? Like the classical simpler model defines it differently, and what that means is if there's a fault proof that goes the wrong way, the whole chain reorgs, 7 days, and in the current optimism, the chain doesn't reorg. So, is it good to
Right.
what it's like? Do you want the chain to reorg if there's a fault proof, or do you want to replace the bridge? And I think, given we know what the state should be, but yeah, I think finality is a term. It's an abstract idea. What matters in practice is questions like, when can I actually use this information that a light client is telling me? And a light client doesn't have to be a bridge. Also, like you could have, I think this is what Celestia does or something, where you like gossip the proofs, P2P or something like this. So, the question is just when. It's actually really weird. Like, do Ethereum light clients exist? I guess, do we have proofs of that? I don't know. I should know this. Like, now Ethereum blocks are provable in real time or close to it or average case or something. But like, light client is pretty important. And yet on Ethereum, everyone just trusts alchemy, basically. Like, how do light clients work on Ethereum?
There's a great resource, Wallet Beat. I don't know if you've looked at them yet. They're doing kind of the L2 Beat style thing, looking at different wallet providers to see who is integrating. Like we have Helios, for instance, right, where we can have some degree of not having to trust the RPC that much, and there's a lot of other work being put in. But they're trying to solve that exact problem in the way of like showing users, hey, don't use MetaMask, right? Go try and use someone who's actually trying to verify what is coming over the RPC.
And so do these wallets, there's a wallet called Unstoppable Wallet. So, they got a lawsuit on their hands now, but does any wallet, verify anything in practice? I'm looking at this thing. I don't see us as a,
No, it's pretty bleak. Some of the applications can embed it themselves and do verification that way. But yeah, for the most part, you have to run your own node.
That is insane. Because no one would ever do that, right? Like,
well, I think that's a lot of the discussion in Ethereum. Like separately, what we're doing here is just like making that easier, right? Like we want to. There's a lot of there's a really cool proposal on Ethereum Magicians for people doing like partial state nodes. We're getting like way off topic now, but now we're just chatting fun Ethereum stuff.
No, I think it's relevant because it's like, in some sense, we demand more from rollups than from the L1 here. In other words, with rollups,
we still have fundamental problems everywhere across the stack, but
we demand the light client to be able to work. And on Ethereum, we all just say, well, Infura, and then Etherscan is kind of like a node proxy for most people. But anyway,
well, I use my node, but yeah, no, there's a lot. Of course, there's a lot of work for people doing like the idea like a partial state node, where you can have someone like run their own node that throws out 99% of Ethereum state that they don't care about, and just at least then they can like trustlessly see their own balance,
prove the rest,
and look at like popular smart contracts on Uniswap, and then that whole thing is going to be maybe like 2 gigabytes instead of 700 gigabytes of state to store.
Yes. So one thing, why don't you just real quick?
Here, I can stop sharing this, by the way.
Let me just show one thing, then we can wrap up here, because I want to give a certain preview of stuff, because we go all the way back here. And remember, I was talking about on-chain consensus, the old model. This was called merged consensus, I believe. I got this from like an Init for the Tech post to look at this. And by the way, when I say it's a meme, I say that people say it, but it's not actually true in production rollups today. Not that it like shouldn't be true, but people don't understand how current systems, factually speaking, work. But anyway, what you'll see here that's interesting, and maybe this previews future thing, is that native rollups, right? Those are a meme or maybe good or something. So native rollups are an interesting thing, and native rollups are a return to the old model, to on-chain consensus, to having a contract that manages the blocks, and then having a precompile that manages the execution. So we shift things back again. So we're kind of coming back, and this is one of my big criticisms with the native rollups notion, is that you get all these downsides again. The upside you get is major because you get on-chain execution, so you get some really secure stuff there. But now you get all these other downsides, and in particular, you get this mega downside of governance can change truth. And so what you see with native rollups is this super secure execution notion, but then how's this going to how's consensus going to work? If consensus is upgradable, then there's no point in a secure execution environment. So, or not environment, secure execution thing. And so yeah, this is worth pointing out because this old model is completely dead, but maybe it's the future in native rollups, which we can.
Well, we're keeping the faith alive with what we're doing, right? And the whole idea is, we're not going to play the game of ever encouraging our users to like trust literally anything that happens on our L2 unless we land on Ethereum, right? And we're going to try and communicate that as much as we can across like block explorers and everything. Because I think this is what matters. And to your point, obviously governance is always a problem, but like a native rollup is like using the native opcode to verify on chain. Like if you look at a conventional rollup and you just simply don't trust it until the proof lands, you can get that same experience, basically.
Well, the native dream, if it's immutable, is you get everything instantly, and
Right.
everything's all good. So I love that. I just don't know how to make it immutable, given that the consensus rules, at least so far, are not posed to be part of the EVM and precompiled stuff. So this is the Leaf wallet. So Celestia, I guess let me ask you this, Satya. So this would be Celestia Lightnode. So obviously Celestia is a data availability thing. So this is for any rollup on Celestia could tap into this, or
I mean, I think the way to get users to run light nodes that are sampling nodes essentially is to integrate them into wallets. Like they shouldn't have to think about it. And so it's starting to roll out across some wallets, but the end game is that as a user, you get your security without having to know you're running a node. The architecture lends itself particularly well to that.
But this literal, I get that makes total sense. This literal product, though, this will work for any chain, any rollup using Celestia as data availability, or
it depends on the wallet you're using, right?
The
asset in question, yeah.
But the idea would be okay, got it.
In the end game, yeah.
Right. Yeah. I mean, I agree with that. I mean, it seems completely. It's funny because it's like if you ask someone how does Ethereum work, who didn't know how Ethereum works, this is probably how they would say it would work, which is your wallet would verify what is going on, basically. So
right.
You didn't have to trust. There's that word again. You have to trust other people. But in reality, it doesn't work like this, which is shocking. And yet, it seems like Celestia. So let me ask you, Satya. Like, is Celestia, way out ahead? I guess I'd ask two questions. One is why is Celestia so far ahead of Ethereum? Do they ever plan on stop winning? On no longer winning? And then the other question would be, if sovereign rollups are so good, where are they? I guess they're sovereign rollups on Celestia. How can I use one of these? Like, are these big? Like, where are the sovereign rollups today? Like, I don't even know where they are. I mean, maybe I'm so Ethereum focused, but anyway, what do you think, Satya?
Well, I think the first, to that question, it's easier to move fast when you start with a clean slate, right? So like by creating a minimal viable base layer that basically just focuses on verifiability and scaling rollups, you can move quicker. Now, obviously, there's different design constraints and trade-offs, and there's no. We can go very deep on all this, but I wouldn't say there's like I don't see Celestia and Ethereum as in competition so much as complementary when you zoom out. I think in terms of, the hard thing for Celestia is creating these applications that are used by people and creating a way of interop between these that works seamlessly. And I think like the reason why you haven't used anything on Celestia yet is because this flywheel hasn't taken off. So native sort of tier interop is just coming online next week in the next upgrade. And sort of the big chains like Converge, Abstract, Noble are launching in the next couple of months. So I would say that I expect Celestia to for most people to actually have used, will have used Celestia at some point in the next 12 months who are already on chain using Ethereum, but it's not apparent right now. I'm also bullish Ethereum though. I think like the community, the liquidity, the philosophy, people like you who can take a stance against the the conventional thought model and still receive like constructive feedback and change things, I think is incredibly special. So yeah, I don't know, that's not a very good answer, but I'm bullish on both. I think Celestia is like particularly underrated right now because, as you say, like people haven't actually, it hasn't had its chat GPT moment, right? People haven't actually touched it yet. But I think we're getting close, although it's kind of very difficult to predict when this moment happens.
Nope, totally makes sense. But I will say, right, like the like Abstract, and I'm sure you're asking even more like major players, but those aren't sovereign, right? Abstract is not sovereign. Do you foresee? You mentioned most people are going to use Celestia in the next X months, but will you also foresee usage of sovereign rollups on Celestia?
I don't know. I mean, like this gets into the semantics, which I think we were trying to avoid. But like, how do you define sovereignty? I think you can have like a validating bridge, and as you say, like gossip proofs, and in a sense, you're still sovereign. So it kind of almost depends on like the nuances of how you choose to spread proofs around your rollout, etc. So I'm not sure if again, how does DA factor into sovereignty is also another interesting rabbit hole. But I'm not confident enough to sort of call any of these rollups sovereign or not sovereign. The sort of hill I'm willing to die on is like the idea of a validating bridge is sort of not a fundamental thing. It's sort of Kelvin Tictor's tweet there. Like it is actually at the center of social consensus for how we think about that rollup, and that then has like downstream implications on how we choose to gossip proofs, etc.
Yep, no, that totally makes sense. I think you are right to catch me on that because my whole thing is like not getting obsessed with terminology. But I'd say a threshold question would be the gas token, just because, and this is going to foreshadow some conversations here. It's like I was kind of dismissive of the claim that an ETH bridged ETH gas token is good, but I think this is kind of a threshold question on the sovereign rope. It's like, do you have a bridged gas token or not? And if you don't, then I would say you're whatever sovereignty, I don't know if you put a label, you're something. And if you have that something label, then you have the extra design challenge of how does your gas token work? You can't just bridge stuff in. And so it has to be a native token. What do? Do you issue it at Genesis and then sell it somehow? Do you issue it over time? At Facet, we're trying to like kind of figure this out. And so I think this is going to be a good future topic of like, if you want your sovereign or however you label it rollup platform to not have a bridge gas token, like what do you literally do? So I think, yeah, that's kind of one defining.
Does having a bridge gas token, do you think it automatically makes a rollup not sovereign? I mean, doesn't it still devolve to social consensus around, you could fork it and implement a new gas token?
Yes, well, I think there are two. Okay, so I'd actually say there are two definitions of sovereign, if we really want that. One definition is a sovereign design, which means no enshrined bridge, which means all bridges are equal. And the other is there a Schnelling points bridge that people in practice have to do whatever it says? And if that's the case, then it behaves non-sovereign. And if it's not, so base would be not designed as sovereign, but it behaves as sovereign because there's no bridge that can actually hold people onto one chain. So I would say from a sovereign design perspective, if you have a native, if you have a bridge gas token, you're not sovereign, and the percentage of canonical assets will always be, so basically the percentage of canonical assets of total TVS is canonically bridged. And if that number is 0, then you're max sovereign. And if it's above 50%, you're not sovereign. And in order to have 0, in order to have the max sovereign, in order to be sovereign designed from scratch, you can't have a bridged gas token. So I would say that according to that, you are, well, actually, let me also say this, right? There's acts as sovereign, but then if you are not designed as sovereign, you will act as sovereign, but you will still have all the downsides of the enshrined bridge. So you will end up with a gas token bridge thing that can't hold people to one fork, but can nuke the chain through upgrades. And so that is kind of why I think the sovereign design is so important, because
but if it was native, if it's a native rollup, how do you see that? Because then obviously you don't have the upgrade risk, right?
Right. So if there's immutable bridges, I would put that, and if it's, native rollup is the best theoretical idea for that. Yeah, if there's immutable bridges, I would put that into a different category. If you don't have the upgrade risk, yes, I would handle that differently. And I would say that I don't know what I would actually say about like a native rollup in this criteria, but yeah, I would say native rollup solves these things. It doesn't have these risks, so is exempt.
Yeah.
And that's why it might be the best overall design if people can get it right. So I'm not. I'm talking.
Yeah, I think what we agree on, like even if the semantics are difficult, is like you either want to be native or sovereign at the end of the day, and like then the question is like what is actually more like pragmatically going to happen, which I think is jury is kind of out.
Yeah, and I think this is, and also foreshadowing, I think there's also kind of a hybrid model where you could have like the native construct is also really a question of bridge security, right? Because the native construct is the idea of making these light clients, basically work perfectly by accessing, the superpower of L1 execution. So the other approach would be to say, okay, it is sovereign. There is no bridge gas token. You have all these bridges, but each individual bridge validates using the native precompile. And maybe we make the native precompile something that accepts as a parameter the state transition function of the rollup as RISC-V bytecode or whatever thing. And so, or a hash of that or something. And so now you have these super secure bridges, which also don't have the ability to nuke the rollup, but are still, can be the best available technology because they use this native thing. So I think there's also kind of that hybrid, model as well, which depending on terminology, whatever. But yes, I think native, sovereign, or both by design, and flipping it, no ability for anyone to either shut the rollup off or, mostly shut it off, which is what would happen with the gas token inflation thing. So.
How bullish are you native rollups on Ethereum?
It's a great question. I mean, I think it's kind of like just the rational, like, end state of this game, right? In a way where why would you want to restrict yourself to not use this? Like, if this is important, like, you should have available. I think the question of consensus is killing the native rollup conversation right now, and it's also kind of unacknowledged, where who decides on what goes into blocks, even if native rollups can execute them. So I think that's like unacknowledged, under-acknowledged, and like no one has an answer for this without upgradability. And then also I think, but I want to work on this, it's part of this grant, but also I think there's just this deep question, we were talking about this in the chat, kind of like, if you can prove the L1 super fast, and we're going to go to super fast blocks there anyway, maybe not 200 milliseconds, but 4 seconds or something. That's pretty darn fast, in my opinion. I'm 41. It's like, what is the lift on native versus just making the L1 more, provable and rollup-y? And I think that's kind of what we've seen recently as these priorities have changed in the EF and as they've announced these new things. And some of these new things I think are completely wrong-headed. Like, for example, this notion that the L1 should be the center for all asset issuance, which I think is like unbelievably not the right idea. But some things in there are good, and I think scaling L1 is good. But like, I think it's kind of sucked a little air out of the room in terms of excitement on native rollups because people are kind of more focused on the L1. But yeah, I think if done right, they're the future. So I want to see if I can help.
Yeah, I mean, I think you get on, like, there's an important thing you raised there. Like, it seems like the L1 scaling and the rollup roadmap, there is tension there, even if it's not acknowledged, right? And it's like little things that you see, like all asset issuance on L1, right? That's kind of when you're saying the quiet part out loud, and it's unclear to me how you, like, yeah, it's unclear to me how great that tension is, I guess, and whether and how much it matters, and whether actually how it plays out. Basically, I don't see it clearly. I think what I like about Celeste's design is it's very clear that it's the L1 exists to scale rollups, right? And so the incentives for me are much easier to reason about on the Ethereum front. I'm not sure. I know there will be value, incredible value created and captured somewhere, but I can't. It's very difficult for me how it plays out, to see how it plays out confidently.
Yeah, I mean, I think that's right. And for me, once I came to understand what rollup actually was, which and kind of the idea how the Ethereum L1 can determine the state of a rollup without actually having to compute it, that kind of core notion. I was like, wow, rollups are sick. Like, let's go. But I also was kind of steeped in ideas about, monolithic L1s and how they're bad and everything like this that kind of affected me. I don't actually know that much about like the proving situation, but if you could actually, do it, have a bajillion gas that only one person has to execute and everyone can verify, then can you just go infinite on this? And of course, Justin Drake had a famous tweet where he said, like, the L1 can go to a bajillion gas, but rollups with the L1 can go to a bajillion times a million or something. It's like, does anyone need a billion times a million on this? Like, can the L1 just do everything? And if that's true, then oopsie, or whatever. But like, we should acknowledge that. But what doesn't make sense to me is kind of, what you're saying. It's like, well, we got both, and we're gonna work on both, and quiet part loud with the assets. We're gonna, to say what is almost an unbelievable statement and see what people say. But yeah, I don't know. I mean, is it possible to do unlimited gas on the L1 as long as proofs, continue? And we're a year from now. I mean, proofs seem to be getting so much better. Like, I should know more about this. I'm like I'm an OP stack guy, so like I'm like not as like schooled with the ZK.
Yeah, so we kind of chatted about this a little bit in the Telegram, right? And I think like the limiter with the ZK endgame for Ethereum, our new like bandwidth war, block size war, I think is going to end up being the resources required to run that prover, right? Obviously, we only ever need one honest prover ever, and then everyone else can just verify the proofs. But if it takes 100 megawatts to run that prover, then we're suddenly too centralized. And so there were some figures thrown around. I think Vitalik initially put out on Twitter that he wanted like 100 kilowatts to be kind of roughly like the prover costs, which is more or less what it's a little bit more than what Succinct had been using for their like almost real-time demo. And that's like a modest size GPU cluster that like people could totally bootstrap on their own if we always wanted to have several of them ready to go.
So why is it in kilowatt? That's such a fascinating, because like when I think about scaling, you think about like, okay, gas per second, and then I think about, okay, like I got my Mac laptop and maybe
this is just a prover requirement.
Right. No, I'm saying like the re-execution model is what type of computer do I need to run to use this much gas to not fall behind. The prover model, now we're talking about kilowatts. Like, why are we? Isn't that like a new?
Yeah, well, because it's like it's hard to do apples to oranges on like GPUs without looking at like, I mean, like how many 4090s is that? How many 5090s is that? You can mix like 10 of those, So I think it's just a one consistent metric. Like at the end of the day, I think that'll break down to specific GPU models, right? Like we know it's Succinct, it was 160 4090s. And so if you want to think of it that way, it's like 160 4090s, and we need at least one honest actor in the world who can muster that power. And it's parallelizable, right? So that can be like a mining pool again, and we can all have everyone in Ethereum running a GPU, and we kind of go back to proof of work, except it's doing useful things this time. Yeah, it's really interesting.
I mean, proving the same maybe, but yeah, I think. But here's my question: so base, you can look up the base node, which I looked up for this, which is hard drive stuff, but like you also need some quality of a computer with some amount of RAM to do the gas per second that base does. And so my question is just, if you look at that apples to apples somehow with the proving, what is the percentages there? Like if you are, you only need X% of the resources to prove base, then you need it to re-execute base or.
Yeah, I mean, I think the trade-off is you need a lot more resources to prove it, and then verifying it becomes almost like nothing, right? Like you can verify any of these proofs on like a smartwatch. Like these are tiny, teeny tiny. Like that's why they get verified by smart contracts already for the ZK enshrined bridges. So I think the idea is then you can have like way more decentralized attesters who are staking their ETH to verify proofs without doing any re-execution at all. And so we can suddenly have like one honest prover can drive Ethereum at insane TPS, and we can still somehow have even more like staker validation.
Right. Okay. So generating the proof is even harder.
Yeah, significantly
than
more
re-executing, but it's much more reusable, basically.
Yeah, you only need one person ever to do it, and then every single person can verify it without having to re-execute.
Right. Whereas with re-executing, you have to communicate that to somebody. You need a whole proof system on top of that, basically. And or I guess you need to do the. I guess the same thing. What am I saying? So yes. Okay. So
it's also easier for bandwidth because with the like the network topology, I don't think is like downloading a block and sharing that peer to peer is a lot more than like the size of a proof. I think proofs are relatively compact once they've been generated.
So it's just how much power does this all take, and power, and that's related to the size of the block gas-wise. I'm sure it's related, but like what are the constituents of the power requirements?
Yeah, it's going to be the worst case block size, which is, or the worst case block to prove, which is a function of the gas limit, and then obviously the slot time determines how long you have to prove it. So right now we're like barely at 12 seconds. If Ethereum comes out and says, hey, we're moving to 4-second slot time, then obviously we are a far cry from doing like real-time proving again.
Right. And then but I guess gas units, do they apply the same for proving? That can't be the case.
No, that's actually why there's a lot of research also going on about whether we reprice, if we're committing to doing the ZK endgame, deciding to reprice like all of the Ethereum gas schedule to bring it more in line with the cost of ZK proving. So for instance, like the big one that people talk about is like the ModEXP opcode.
Yeah.
Is like grotesquely mispriced for ZK proving. So like you could make a block that was just full of like ModEXP operations until it fills up the entire gas limit, and that's really cheap to re-execute. But if you try and ZK prove that, it'll like destroy performance. And so the idea is like, do we want to make this opcode like way more expensive than it would otherwise cost to do normal re-execution to bring it in line with how much it would cost for ZK execution? And that's also why there are some other ideas about like scaling Ethereum by making storage a lot more expensive, but making the compute operations like pretty much free, because like some of those are even like kind of mispriced still. Like add and multiply are pretty much free on like all modern hardware. But like if you want to stop state growth, like 10x the gas limit, 10x the storage cost, keep compute super cheap, and then you can have like really interesting design space happen where people aren't really storing anything on Ethereum, but they're doing a lot of proof verification.
And so this is the meme that state growth is worse than computation. I feel like I've read other tweets that say that's a false meme or something.
Yeah, I'm not really. I don't think state growth is actually a problem. There's a really great article from Paradigm about like looking at hard data on state growth. It's from last year, so it's a little out of date, but it was like on normal consumer hardware, storing just the state is viable for like the next decade.
Okay. But then again, you had base 500 gigabytes a week. But I guess the idea is Ethereum is going to be slower than base or something. But
Well, Ethereum's, yeah, definitely got a lot less state growth than Base. Just because it's like, 12-second block time and
But it's
expensive.
gonna go to 4 and like whatever, but
Yeah.
anyway, something.
No, the
But
end goal, we really need like either state expiry or we need partial state nodes. I think partial state nodes will solve a lot for a lot of users, right? Like if you could give someone like, hey, download this is Ethereum, and it's like 2 gigabytes and it has everything that you need to like do the important things on Ethereum, right? Like it's not going to include every single ERC20 and every single NFT ever. It's not going to include like defunct smart contracts that no one has ever used in a decade. You can cut probably 90% of the state out and just give them like popular coins and USDC and
right.
Uniswap and a few DeFi primitives. And you can make different packages, right? Like here is Ethereum DeFi. Go download it. It's 10 gigabytes. You're good forever. Run it on your own machine. You have privacy now. So I'm like very interested in that sort of work.